Hello everyone and welcome to this video of the course Robotics. In this video, we are going to work on PWM pulse width modulation. In the previous video, we have already seen the idea and the concept of PWM, and it can be used to control the speed of a motor, or it can also be used to control the brightness of an LED. And we are going to do the same thing in this program. We're going to control the brightness of LED. As we know, the PWM channel is available on 6 pins in Arduino, that is pin number 3, 5, 6, 9, 10 and 11. But the onboard LED that we are having is on pin number 13, so we cannot use the onboard LED to control the brightness of it. That can be done in one way if we can short the pin number 11 and pin number 13 altogether. Or otherwise, we can connect a separate LED on pin number 11 as well. So we'll be trying on both the ways. First we'll write the program for it. So let's write a program for this. We'll be using pin number 11, so we'll be declaring int LED equals to 11, and as pin number 11 is a digital pin, and we know that digital pin can be used in both the modes, the input mode and output mode, and it is necessary before using them to declare the mode in which we wish to use them. So we'll be declaring them by writing pin mode of LED, output. Now in case we wish to control the brightness of LED and we wish to make it go from dim to bright and bright to dim like that, so in that case we can declare a variable I, that is int I equals to 0, and come down, and here you can do one thing, that we can use for loop over here. So for I starting from 0, that is I equals to 0, and I going up to 255, so I less than 256, and I plus plus, that's increment of 1. With increment of 1, we can every time write the value of I to the analog pin 11 using the syntax analog write. So we'll be writing analog write 11 comma I, and with every bit we'll be putting a delay of 10 milliseconds. So the final time which the LED will take to go from the dim to brightest position will be approximately equals to 2.55 seconds. Let us say that after switching up to the complete brightness, we want to make it stay on for some time, so we can make a delay of around 100 milliseconds out here. And now in case we wish to bring the LED's brightness from brightest to the dim part again down, for that we can initiate another for loop. So for I is equals to 255, I greater than 0, and I minus minus, and we'll be writing analog write 11 comma I, and the delay with every write will be putting off 10 milliseconds. And after the switching off, we'll be putting a delay of around 100 milliseconds so that we can see it completely switching off. So once we're done with programming, we can now save the program, compile the program, and upload the program. Let's save it with the name program3, compile the program, and upload the program. Now we need to match the pin number, we need to short the pin number 11 and pin number 13 so that we can see the output with the onboard LED. For that, we'll be connecting pin number 11 and pin number 13 altogether so that you can see the output, the brightness of LED going up to down, so that you can see the output, that's the brightness of LED going up to down and dim to bright, bright to dim, like that. You should be able to observe the brightness of LED going dim to bright and bright to dim. We can also use a separate LED as well for this by connecting with Arduino on breadboard. Now you should be able to analyze the brightness of a separate LED also going up to down and down to up. That means going bright to dim and dim to bright. So this is the main objective of this program, to control the brightness of LED using PWM. And in the next program, we'll be implementing the similar technique to control the speed of a DC motor. So thank you for watching this video and stay tuned for further exciting videos.